Alright, hello class. So in this video we're going over sigma notation. So let's just say that we have a sequence of numbers. I'm going to call it a sub n, and it's equal to n squared plus n minus 1. And we want to add this for n equals 1, then 2, then 3, all the way till 20. In other words, we got a sub 1 plus a sub 2 plus a sub 3 plus dot 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 until plus a sub 19 plus a sub 20. Okay, what in the world does that even mean? So, this over here is called the index. So these numbers, as well as that variable, they're called the index of the sequence. Versus, if we look at the whole thing together, this is called the sequence. I've also seen it called the argument, because argument in mathematics just means the thing that gets put into something else. And this gets put into what we call a summation. You'll know what that means later. So, therefore, argument. Alright, so what happens then is we have the argument being added several times. How many times? Well, n equals 1, 2, 3, dot, 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 till 20. And then, essentially what we're doing is we're plugging the index into there. So all of the n's, they just become 1 first, and then 2, and then 3, and then 4, all the way until 20. And you're adding all of those individual arguments up together. That's the goal of what we're doing here. So we're just adding a whole bunch of stuff. And it is very tedious to write this entire thing out over and over and over and over for every single number 1 through 20. Sometimes things will require 1 through like 1,000. So how can we write this in a way that's easier and quicker and easier to understand as well? So something more efficient. Well, we have this letter. This is sigma. This is the Greek letter for S, big S. Not quite sure how that turned into this, but it did. So, let's figure out a way to write that thing up there. So, if we let k equals 1, and then let that go to 20, and then add in the argument, k squared plus k minus 1. Notice that I didn't use n, I just used k instead. I prefer to use that for several different reasons. One of the main reasons is just because when you do summations like this, you end up with having to use n for something else in a lot of applications. So I just use k. There's nothing special about it though, really. So, what we're doing is we're going to add up this thing, starting with k equals 1, ending with k equals 20. That's what this says. So this literally just equals 1 squared plus 1 minus 1 plus 2 squared plus 2 minus 2 dot 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 until 20 squared plus 20 minus, wait, that's supposed to be a 1. Sorry about that. Okay, so let's practice. So write out the given sum. So 3 to the k is our argument, and we're starting with k equals 3, going until k equals 6. So we're going to do 3 to the power of 3, plus the argument again, except now the index has gone up by 1. So we get that, and then 3 to the power of goes up again, 5. 3 to the power of go up again, 6. And then that's all. So I'm just going to kind of talk about how to go through this in an easier to do way, so you don't have to necessarily use a calculator. So here's a smart way to add this. There's a factor of 3 to the third in each of these. So let's just do that. 3 to the third, and that's 1 plus 3 squared plus 3 to the third. Because who knows what 3 to the sixth is off the top of their head? If you do, good for you. Alright, so 3 to the third is 27. That's more or less easy to just figure out pretty quickly because 3 times 3 is 9, times 3 is 27. Okay, so this is 9, this is 1, this is 3, and that's 27. So we can actually add this fairly easily because the 9 and the 1 can add to make 10, the 3 into 27 can add to make 30. So getting 10's, easy way to add. 27 times 40. Okay, so this is basically 4 times 27 and then times 10. So 4 times 27, we get 8. So 28, and then 8 plus 2 is 10. So we get 1080 here. Alright, so let's try another one. Here we have two t's. So you're just going to substitute this into both t's. I've heard things before of people asking, wait, which one do I substitute that into? This just means wherever you see a t, you plug the number in. Alright, 1 over 1 plus 1 plus 1 over 2 plus... sorry. That should be 2. 2 over 2 plus 1 plus 3 over 3 plus 1 plus 4 over 4 plus 1, and we stop there because our index says to stop at 4. So that's 1 over 2 plus 2 over 3 plus 3 over 4 plus 4 over 5. Alright, so let's just combine these. I'm going to combine those two and those two at the same time. So common denominator there is 6. So we get 3 plus 4 over 6. And a common denominator here is 20. So we get 15 plus 16 over 20. Add those together, we got 7 over 6, and we got 31 over 20. Okay, so what is the least common denominator here? Looks like 60. Let's go for it. So multiplying 10 up here and down there. And then multiplying 3 over 3. 70 plus, I believe that's 93. All over 60. So then we end up with 163 divided by 60. I believe this does not reduce, so we can leave it that way. If it reduces, let me know in the comments. Alright, so let's look at how to actually get a summation itself then. So say that you're given a sequence of numbers, how do you actually get the summation? So first thing is, let's look at patterns here. Here we have 1, then 2, then 4, then 8. We can already start to see something happening here. So one thing you might notice is 1 times 2 is 2. 2 times 2 is 4. And then times 2 is 8. And then 64. That can help us figure out where we're going to end, because we already notice here we're just doing 2 times 2 times 2 times 2. So this is what's called powers of 2. So we're pretty sure then our argument is going to be 2 to the power of, let's use a variable, I'll just use n this time. So we want the first one to be 1. So 2 to what power equals 1? 2 to the 0 equals 1. Okay, so where are we going to end though? So if these are powers of 2, then 2 to what power equals 64? Well, we know that 8 times 8 equals 64. So that's 2 to the third times 2 to the third, which is 2 to the 6th. So we're going to end at 6. So notice what we did here was just see the pattern and then try to construct something from there. And basically figure out what's the argument, and then what is the lower and upper bound. Alright. Next, let's look at this. What do we see here? We see two things happening. We see something with a numerator. So the numerator is 1. What about the denominator? So it is 2, 3, 4, 5 dot 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 20. So just increasing numbers from 2 to 20. So we can already tell that at some point in our summation, we're going to get 1 over k. And k is going to start at 2 and then go to 20. So notice I put a space here. There's a reason for that, because this alternates adding positive and negative. Because we got positive 1/2, minus 1/3, positive 1/4, minus 1/5, dot dot dot. So all the evens are positive and all the odds are negative. So how do you make things positive and negative? Well, -1 helps. And if we want the even powers to be positive, then we want this to be -1 to some even power. So if k starts at an even power, we can just make that k. Because if you think about it, -1 to the k power, if k is 2, this is going to be positive. So that gives us positive 1 over 2. And then if we go to 3, then -1 to the third power is -1 times 1 over 3. So we get minus 1/3. And the same pattern is going to just go throughout until we get to k equals 20. All right. Now let's look at this thing. So we see a few things in common already. We see delta x in all of them, so we're probably going to have to somehow use delta x there. And then we also have this function. So somehow that's going to be in our argument. And then notice that there's kind of a sequence going on here. We have delta x, 2 delta x, 3 delta x, and here we can think of that as 0 delta x, even though there's nothing there. It's just helpful to see that pattern and think of it that way. So our summation is going to be, we know that there's delta x and an f of something. What else is in common in all of them? 1. So we know we're going to have 1 plus something. If we look at it like this, we got 0 delta x, 1 delta x, 2 delta x, 3 delta x. So let's choose a variable to multiply this to a, because why not? So a is starting at where though? It's starting at 0. And then what's the last value for it? We got 3, so this is the summation that you would get from that. It looks kind of complicated and weird at first, but once you really think about it and just break that down, we got this thing right here. Alright, that's the end of this video, so hopefully this was helpful. See you in the next video.